Hi everyone. Today's topic is first class functions. Functions that are first class. We learned first order functions before, and now we are gonna learn first class functions. What are they? First class functions are values, while first order functions are not values. What does that mean? That's gonna be the topic for today. Review some important things about first order functions. Remember, when we define a new function, we use this keyword def. This one says that I'm defining a function of name twice, which takes one parameter, and this is the function body. And we can call it using twice open, twice close. If it's not an online lecture, if I can see you guys, I would ask these questions to you and we can have live discussion about these examples, but that's pity that we don't do that. But before I tell you the answer, you'd better think, right? Think about it. What's the result of evaluating this expression? First of all, what is this expression? You think. Yeah, it's function call. It's function name, open, close, some argument expression. What do we do with this function name? Look up the list of function definitions. Here's only one function definition and see whether we have a definition for this name. Oh, yeah, we have this. And then let's evaluate the argument expression. What is that again? It's twice. It's an identifier. How do we evaluate an identifier? Look up the environment. What's the current environment? Sigma? Empty. It's what? Empty box, empty blue box. So when we look up the environment using this name, it's gonna be what? Free identifier error. Yeah. What's next? We have function definition x, whose parameter name is y. And the expression to evaluate is a local identifier introduction. We introduced a name x whose value is 5. Using that information, what is that? Again, function call. We are calling a function x. So here we have two x's, right? Function x and this local identifier x. Because this is function call syntax, whenever we have a function call syntax in AE, right? That's going to be a function name, not this local identifier. So we are calling this function with the argument value 7. So the result is going to be what? 7. What's next? Identity function. We are calling identity function using number 3. Yeah, nothing surprising here, right? What about that? Oh, we have two definitions for one single name. It's called, it's called overloading. Function overloading. Java has that, Scala has that, several programming languages have overloaded methods or overloaded functions. Meaning that, when we have just one single name, f, there could be several declarations, meaning that this one, it's int, returns, say int, and there's another function, f, which takes string and returns int. Then you can say, I'm going to call this function with hi. Then which one am I calling? This one? No, because it expects an integer. I'm calling this one. So that's overloading if it's allowed. But in F1VAE, did we allow overloaded functions? Not really, because you don't know what that means, right? So in this example, in this code, even though we have two definitions for one name f, only one is available. It's just like what? Like shadowing or hiding that we discussed. But the thing is that we have not yet discussed which one wins over the other, right? It depends on how we can look up the function definitions in that FDs, if you remember. So this one depends on which one we are looking at, but if we use the same philosophy with local identifiers, the closer one is supposed to win over the old one, so this one may be what? 5. Okay, what's next? Ooh, can I delete this? Okay, what is that? We defined a function f, and then we are calling it. So far so good. What is f? This function definition. Let's pass 3 to the argument. And what is that? It's an identifier. It's not a function call because it doesn't have open expression clause, right? We don't. This is an identifier. Happen to be the parameter name. So the result is, 3. What's the last example? The last example is everything is f, right? We defined a function f whose parameter is f, whose body is f, and we are calling the function f with f. Ooh, everything is f. Looks fishy, right? What's the result of evaluating this code? Here we defined a new function named f, and now we are calling some function f. So when we have this function name, we look up the function definition list and we found it. Okay, good. Now we need to evaluate the argument expression f. It's an identifier. How do we evaluate an identifier? Look up the environment, which is empty. Again, empty blue box. It's a what? Free identifier error. Okay, so these are all simple examples. And you should be able to evaluate these expressions by yourself. Then you understood the semantics of F1 VAE. Then what's the main topic for today? First class functions. What are they? Functions that are values. They are functions and their values. What does that mean? One more time. First order functions in F1 VAE and first class functions that we are going to learn today in FVAE. They are both functions, but functions in F1 VAE are not values. And functions in FVAE are values. Meaning that this function definition f is not a value, but this function expression anonymous function is a value, and we can give it a name and call it. If you still don't get it, don't worry, let's see. One thing to note is that in first order functions, when we define a function, we need this keyword def, meaning that it's not an expression, it's a function definition, a different kind. Remember, in F1 VAE, we had 2 kinds of non-terminals, right? Function definitions and expression. But in first class functions, functions are just like other expressions, right? Just like 10, it's just a function expression, open, close, arrow, that signals that we are defining a function expression. So in mathematics, these first order functions are like named function. We are defining a function f whose parameter is x and the body is 1 plus x. And in mathematics, this unnamed function is like that, lambda expression. It's a function expression which takes one parameter whose body is that. Okay, so we are gonna learn this thing today and this Wednesday. So if you don't get what first class functions mean clearly today until the end of today's lecture, don't worry, we are gonna cover this Wednesday, and you're gonna learn the operational semantics of functions as values, which should help you understand this concept better. Let's review what F1 VAE one more time. As I said just before, we had 2 kinds of non-terminals, FDEF and expert. And what? FDEF was different in the sense that it was defining a function, and expression, they are the usual thing. When we define a function using the keyword, we define it and we call it by name. FVAE, that's the language for today. We do not have a separate non-terminal for function definitions. There's only one non-terminal for expressions, meaning that function introduction and function use, both of them are now expressions. So as we saw some examples before, when we construct a function expression, we use open, close. Between that, we have a parameter name, arrow. 화살표가 있어요. From here to there, that's a function expression. It has a parameter and a body expression. For example, we can say that open, close, I have a parameter x, and when we have an argument value for this parameter, the body is that. It's a function expression. Again, just like F1 VAE, this function expression takes only one parameter. And you should be able to extend this syntax to take multiple parameters. If you want to see what that means, what I mean by that, you may want to take a look at project number 1. Some students already are asking questions of project number 1, but it's not yet ready for you to understand project number 1 because it contains many concepts that we are going to cover just before the midterm exam. So it's good that you are taking a look at that project number 1 earlier than later, but don't panic if you don't understand the material yet. So when we introduce a function expression in FVAE, it's gonna look like that. Then how can we call it? If we introduce a function expression, a function value, we'd like to use it. How can we use that? This was the old syntax, right? Old syntax for function call in F1 VAE. At that time, we knew its name. Because in F1 VAE, when we define a function, we already defined it using a name. But how about FVAE? It does not have a name, right? It's an anonymous function, and it's unnamed function. 이름이 없어요. 이름이 없는 함수예요. 얘 어떻게 불러요? How can I call it? Oh, you know what? There are two ways actually. You can give it a name, make a function expression and give it a name by using this local identifier introduction. Hey, I'm gonna call you F. I'm gonna give you a name F and use it by calling it. Or you don't even need it. You can just write it here. When you call it, just write the function expression. So we need to change this syntax, right? It's not only by name, but also by some function expression, or rather any expression. In concrete syntax, in FVAE, when we call a function, we do not need a name here. We can just have arbitrary expression which evaluates to a function value. Either name or function expression or some other more complex expressions here. Isn't it cool? It could be like some other val blah expression. It doesn't need to be a name nor a function expression. It could be any expression. That's what the syntax says. Let's look at some examples. In FVAE, evaluation of those arithmetic expressions remain the same. Evaluation of name introduction remains the same. Just like Y in F1 VAE, Y in FVAE is a free identifier error. So far so good, right? Because the results are either numbers or a free identifier error. What about function expression? When we evaluate a function expression, we get the function expression, right? because functions are values. That's the main difference of FVAE from F1 VAE. So the result of interrupt, the result is not always a number. It could be a function expression. So the result of interrupt function is not anymore int, but now value. Let's see. What are values? We are going to define that over the lecture today. Look at that. This is an expression. We give a name f to a function expression, meaning this is a function value. And we can call it. When we have this function call, that's going to be E1 open, E2 close, right? So what is f? It's a name. What do you do with a name? Look up the environment. In the environment, we have this value. Oh, so cool. That's the value. And then argument 3. It's a function call, so we are going to pass 3 to the parameter. Then it's going to be what? 1 plus 3, which is 4. Obvious, right? How about 1 open, 2 close? We evaluate the first sub-expression E1. It's not a function value. We are expecting a function value, so it's an error, not a function. In addition or subtraction, whatever arithmetic operator it is, when we have that, we expect two numbers, but one is a number, the other is a function, not a number error. Okay? In F1 VAE, again, we had two kinds of non-terminals, fdef and xbar. In FVAE, there's only one xbar. And we have the usual function call app. Previously, it was string and an expression, but now it's two sub-expressions, right? Function expression now takes only two fields, parameter name and body expression. You should be able to write down these abstract syntax by yourself. Even though you don't have a parser, when we have this abstract syntax, you should be able to write down some test code by using that. Yeah, you should be able to play with this abstract syntax even though you don't have a parser. Again, yeah, parser will be given. Don't worry, but when you do some exercises and when you do some coding, you should be able to write down a parser, but you don't want to, right? I don't think you want to write your own parser. Then you should be able to play with abstract syntax, just like a value. Okay, F1 VAE interpreter, there's only one function called app. Now FVAE, we have two new things to evaluate. Previously with F1 VAE, inter function took what? 3 arguments. FVAE, an expression to evaluate, an environment to look up when you have a name, a list of function definitions to look up when you have a function name. In FVAE, now we do not need FDs because function definitions are not necessary here. And another difference, in previous interpretation, the result was always integer, but now it's not always an integer. It could be function value. It's not exactly true. It's not true. We are going to revise that after the break. Okay, then. So when we have a number, we are going to return it. When we have addition and subtraction, they are the result of interrupt calls, recursive calls, do not return integers anymore. They are going to return xbar. Then what can we do? We need to manipulate that. We need to get real integer values out of that. So we need to define extra functions, numadd and numsub. What are they? Numadd takes two expressions. Why? Because the return type of the interrupt is xbar. It takes two expressions and return another expression. Why? Because the return type of interrupt is xbar. Right. Then what are we doing? You know what? Numadd takes two expressions, x and y, but we hope they are numbers. Otherwise, it's an error. So let's do pattern matching. If both of them are indeed numbers, then we know that they have numbers. And we get those numbers, add them, and put num back. For subtraction, the same thing happens. Ooh, do you see that? One more time. When we have subtraction of two expressions, we look at those expressions. There are how many expressions in this language? Num, add, sub, val, id, app, 6 kinds. But when we want to do addition or subtraction, we want them to be two numbers. All the others are going to be errors. Yeah, they should be both numbers. When we have two numbers, get rid of this constructor, get the argument values, do the calculation, do the arithmetic expression, get an integer value, put num back to make it expert. Okay, do you see that? And they look just the same. When we have multiplication, when we have division, when we have more operators, we need to copy and paste this code again. That's too bad. A better idea to implement that is to have the standard version num up, which it takes an operator, as the first parameter and then two expressions and do the same thing. Meaning that when we have two expressions, we check the usual thing, but the operator is gonna be the argument. Meaning that num add, num sub are what? Calling num up with addition and subtraction. Because their definitions are just the same except the operator. If you don't get this code, don't worry. It's a use of first class functions that we are going to learn this week. Now let's take the first break. We're going to come back with the implementation.